Hello everyone, today we are looking at lesson 2.1, rational functions, key features from a graph. So today we are going to be looking at rational functions, which are different from any other kinds of functions that we've looked at before. However, they're going to have very similar qualities, but also a few different ones. So by the end of today's lesson, your goal is to be able to identify vertical asymptotes, horizontal asymptotes, wholes, zeros, and domain from a graph. So let's start by taking a look at its parent function. So a rational function is an equation where the numerator and the denominator are polynomials. For now, everything we're going to look at is going to be a rational function, and we'll get into what a polynomial is later in the year. We've talked about many different parent functions in our last unit. We had quadratics, rationals, exponentials, and absolute value. Now, we have a new parent function, and that's this rational function. So the parent function is going to be f of x equals 1 over x. And you can see to the right what this parent function looks like. It's a little bit different than any of the graphs that we've looked at before. So today we want to identify what are the key features of this graph. So let's take a look at the different pieces of this graph. So let's take a look at this graph. F of x equals 1 over x. It's got a lot of key features that we're going to discover as we go through this lesson. So think about some of the things that you notice. Well, this is a little bit unusual compared to some of the other graphs we've seen. If we look at our x and y axis, the graph never crosses. So we don't have any x or y intercepts. But instead, we have like a boundary. These graphs get really, really close, but they're never going to cross or touch these boundaries. And we're going to call these boundaries asymptotes. Hopefully you remember that from the exponential function in the last unit. This particular graph has horizontal and vertical asymptotes. If we look at our x-axis, it gets really, really close to this line, y equals 0. But it never crosses or touches this line. So this means that we have a horizontal asymptote at y equals 0. We have the same thing if we look at our vertical axis, the y-axis. We have this boundary here that this rational function never crosses. Since we have a vertical line, we have a vertical asymptote. And our vertical asymptote is going to be at x equals 0. So some other things that we can notice is that's going to affect our domain and range. So remember, our domain is all our x values and our range is all our y values. So our domain is going to be all real numbers, except it's never going to be 0. So x can't be 0. Our range in this case is going to be really similar. It can be all real numbers, except y can't be 0. Because like I said before, it's a boundary. It never crosses or touches that line. So these asymptotes are going to be some key features we're going to look at on all our rational functions. We're going to take a look at another graph that's going to give us a few more key features of rationals. So let's take a look at number 17 from your homework yesterday. Number 17 was f of x equals 2x squared minus 2x minus 12 divided by x squared minus 9. This is actually a rational function. You guys factored it, and we're going to look at factored form tomorrow. Today, we're just going to take a look and investigate its graph. So when we take that function and we put it into Desmos or a graphing calculator, this is the graph that we get. So we can notice that we have some similar key features to our parent function, 1 over x, as we have a vertical and a horizontal asymptote. However, this graph also has some differences. First thing we can notice is we do actually cross the x-axis, and we cross the y-axis. We do have an x and y intercept. We also have this open circle, and this open circle is going to be a whole or a removable discontinuity. So that means the graph does not exist there. And then we're going to take a look at the domain as well. So the key features we're looking for on each of our graphs are vertical asymptotes, horizontal asymptotes, zeros or x-intercepts, holes, and the domain. So first thing we want to take a look at is vertical asymptotes. So if we look at where our vertical asymptote is what line can we draw that these two pieces of our graph are approaching but never crossing? And that's going to be right here when x is at -3. So that is going to be our vertical asymptote. Remember, our vertical asymptote is always going to be the equation of a line. In this case, it's going to be x equals -3. We also have a horizontal asymptote, and our horizontal asymptote is our horizontal line that our graphs are approaching but never crossing. So we can see that on the y-axis, this is going to be at y equals 2. Then we want to identify any zeros or x-intercepts. Zeros and x-intercepts are the same if we remember back from Algebra 1. So here we cross right here. So that's going to be at x equals -2. And then we want to take a look at our holes here, or any removable discontinuities that we have. So in this case, we only have one, and that's going to be where x is equal to 1. Now, when we get into looking at equations, we're going to find the exact point of our hole. But in this case, we can see it's roughly at about 1.5. But for now, we're just going to identify that as x equals 1. And then last but not least, we should be able to identify the domain from this graph. So our domain, remember, is all of our x values. So we're looking at our x-axis. So our domain is going to be all real numbers because our graph is going to extend on, except x cannot be -3 because we have a vertical asymptote there, and we know that our graphs are never going to cross there. So there is no points that exist on that line. So there's no x values at -3, and there's also no x values at 1 because we have a hole there. And since we have a hole, x can also not equal 1 because our hole means there's no part of the graph there. And if there's no part of the graph, there's no x value. So anytime we're looking for domain, we want to look at the x value of our hole and our vertical asymptote to help us define this. So for this graph, our domain is going to be all real numbers, except x cannot be -3 and x cannot be 1. So we're going to look at a few other rational functions that may look very similar or very different, but we're still going to identify these same key features. Now we have a new graph, but we still want to take a look and find all the key features from this graph. So we still have vertical asymptotes, horizontal, zeros, holes, and our domain. So vertical asymptotes, we're looking at where can we draw a vertical line that this graph is never going to cross. And that is going to be right here at x equals 2. So our vertical asymptote, we only have one here, is at x equals 2. We also have a horizontal asymptote where our graph is approaching at y equals 1. If we look at our graph, we do cross our x-axis, so we do have a 0 or an x-intercept at -5. So our 0 would be x equals -5. Next, looking for any holes, if we look at our graph, it's continuous. We don't see any open spots, so we have no holes. So holes, we have none for this graph. So our domain, we always want to look at our vertical asymptote. And our vertical asymptote's at x equals 2, which means our x-axis has no points at 2. So our domain is going to be all real numbers, except x cannot equal 2, because we have that vertical asymptote or that boundary there. Now, we're going to take a look at a different rational function, and this one's going to look a little different than the two that we've just taken a look at. All right, so we have this rational function. This one's different than the others. It has 3 different parts, but we're still looking for the same key information that we have located on the right. So we're going to start with our vertical asymptotes. So vertical is where are these graphs approaching on our x-axis. So we can see right here at x equals 0, we have a vertical asymptote. But we can see that we also are approaching x equals 3. So we have 2 vertical asymptotes here. But if we look at our horizontal lines, we can see that it's approaching x equals 0 up here, but this graph down here is not. So since not all 3 pieces of our rational function are approaching one horizontal line, we have no horizontal asymptotes. So what is our horizontal asymptote? We have none. Looking at our x-axis, do we have any places where we cross? On this graph, we don't. So we don't have any zeros or x-intercepts on this graph. Then if we look for any holes, our graph is continuous. We have no open spots on our graph, so we have no holes. So this graph only has vertical asymptotes. That's the only key feature we're looking at here. But since we have vertical asymptotes, we do have a domain that is restricted. So our domain is going to be all real numbers, except x cannot be 0 and x cannot be 3. Because we have 2 vertical asymptotes here, so the graph will never cross those spots on the x-axis. The next 3 slides are going to be practice for you. So what I'd like you to do is pause the video, copy this down, try it on your own, and then when you hit play, we'll go through the answers. So hopefully you have gone through and you found the vertical asymptote, the horizontal asymptote, the 0, the hole, and what the domain is of this function. So our vertical asymptote of this function is going to be x equals 5, because that's where both of these graphs are approaching. The horizontal asymptote is going to be at y equals 1. Our 0 is going to be approximately at x equals -3. We have a hole at exactly 7, 5. So before we just wrote what x equals because we couldn't definitively say where the hole was. The hole is an actual ordered pair. So in this case, we can tell that this ordered pair is going to be at 7, 5. The graph is a removable discontinuity here because this graph is not continuous. It does not go through this point at all. So this would be a hole in the graph. And finally, our domain of this function, looking at our vertical asymptote, is going to be all real numbers, except x cannot be 5 because the graph will never cross on the x-axis at 5. The graph can also not cross at x equals 7, because if we look on our x-axis at 7, we have a hole. And at that hole, that means the graph does not cross, which means at x equals 7, there is no piece of the graph. So that does not belong in our domain. So our domain is all real numbers, except x cannot be 5 and x cannot be 7. Now for our second practice problem, pause the video, copy it down, and give it a try. Then come back and hit play for the answers. Now this graph looks a little bit different. So if we look at this rational function, it's a little bit different from the other ones that we had looked at. However, we're still looking for the same pieces of information. This graph has a vertical asymptote. So if we start with our vertical asymptote at, it's actually drawn in for us here. So we can see that it is approaching x equals -3. There is no horizontal asymptote. The two pieces of this rational function, it's never going to cross, do not approach anything on. If we look for a horizontal asymptote, there isn't one have in this case. We can see that neither pieces of this graph are approaching anything. However, this does have on our horizontal axis. It crosses so we have equals -4 horizontal asymptote, and x. If we're looking for zeros, we're always looking at our x-axis. This graph also has a hole, we actually cross, and it has a hole at 2 different points. So we have 2 zeros. 1. And our zeros would be, and our domain is going to be all real numbers. 4. And, except taking a look at that vertical asymptote, it cannot, 1, be -3. Actually, 2. Then if we look for any holes, we're looking for open spots on our graph. So in this graph, we actually have a hole at 0, 1. So that means looking at our domain, it can be all real numbers, except if we're looking on our x-axis, we want to see points where it doesn't cross. And it's never going to cross our asymptote at x equals 3, or at our hole. It's never going to cross the x-axis at our x-coordinate of our hole, which is x equals 0. So our domain is all real numbers, except x cannot be -3 or 0. Now for our last practice problem, go ahead, pause the video, copy it down, try it, and then come back for the last set of answers. So here we have a rational function, and we're looking for our key information. So here we have a vertical asymptote at x equals 4. We have a horizontal asymptote at y equals 0. It never crosses the x-axis, so we have no zeros. There's also no holes. We don't see any open circles on this graph. That means this graph is continuous and there's no open circles. So we don't have any holes. And our domain, once again, we look to our vertical asymptote to help us identify our domain. So our domain is going to be all real numbers, except x cannot be 4.